So we left off on this section right here. We have just determined the P wave travel time to reach this station in Tibet. And it was 5 minutes and 40 seconds. So if it took that long for the wave to reach us, and the wave reached us when our clock said 1:04:30, then how long ago was the earthquake? So it's this time minus the time it took to get to us. Once again, I'm going to use this list of steps to make sure we don't make any errors. So first we're going to subtract the hours, and 1 minus 0 is 1. Then we're going to subtract the minutes, and 4 minus 5 is negative 1. So now the minutes are negative. So we have to follow these steps here. Add 60 to the minutes. So if we add 60 to negative 1, we get 59. And subtract an hour from the hours. So 1 minus 1 is 0. But we don't really say it's 0 o'clock, right? We call that 12 o'clock. So I'm turning that into a 12 for time, the purpose of time. So just to clarify, because this is getting kind of messy, so far we have 12:59, but we haven't done our seconds yet. Now you can see when we do our seconds, we're going to get a negative number, right? 30 minus 40 is negative 10. So once again, we have to follow this series of steps, add 60 to the seconds. So that's going to be negative 10 plus 60 is 50. And we also have to now subtract a minute from the minute column. So this is going to be 59 minus 1 is 58. So that's kind of sloppy, but this is the ultimate answer. So this is what the clock read when the earthquake occurred. And 5 minutes and 40 seconds later, it arrived to us. And our clock read 1:04:30 when it arrived. So I hope that's not too confusing. I know it's a lot of math on time, but I think I've walked you through the steps pretty carefully. Let's do the next one. So at the KMBO site, if you recall, we found a distance of 6,800 kilometers from the epicenter based on this 8-minute separation time between the P and S waves. And so again, we're going to look at how long did it take that P wave to arrive to our station. And so we're going to look over here at the intercept, and it took about 10 minutes and 20 seconds for the P wave to reach us. So again, we're going to put that right there, and we're going to have to subtract the two to figure out the time of the earthquake. So hopefully you can figure out how to do this now on your own. Maybe pause the video and see if you can follow those steps. I'm going to give you the answer right here, 12:58:28. So we're going to put that in there. And you'll notice these times are fairly close. They're within about 22 seconds of each other. And that's the whole idea. The earthquake happened at one moment. So we want all three of these answers to be very similar to each other. So you're going to be doing the Guam one on your own. Hopefully you'll get a number that's pretty close to one of these. All right, now that's the end of part 1. Unbelievable, right? But that was the main bulk of the lab. So let's move on to part 2. Now we're going to pinpoint that epicenter a little bit better. We're going to repeat what we did in part 1. So you're going to use map 2 for this one. Make sure you have map 2 and not map 1. It looks similar to the other one, but if you notice, it's more of a close-up. And the first thing I want you to do is label these various locations, because I want to make sure you know where we're looking in the world here. Then you're going to follow the same procedure for these 3 seismic stations. You're going to look at when the P arrived, the S arrived on the seismograms that are provided. You're going to figure out the time difference, and you're going to use the time travel curve to get the epicenter distance. So you're going to repeat everything we just did for these 3 additional stations. And again, you're going to make the circles on the map and then find the intersection and label it the epicenter. And it should be the same location as the epicenter on map 1, because this is all recording the same event. Part 3 has to do with the tsunami waves. You should read this little section here. Basically, the tsunami starts where the epicenter is, and that wave travels out in all directions. So I'm going to show you what this is going to look like, but I'm not going to give you the correct answer, if that makes any sense. So here's the map. Here are 3 circles that I've put on here, which would give me an epicenter right here. But this is not correct, okay? This is not the right size of the circles. This is not where the epicenter is, but I don't want to give the answer away. I'm doing this because I want to show you how to do the tsunami part. So pretend that this is where the epicenter is, even though it's not. Now it tells you here that the tsunami traveled at about 600 kilometers an hour in the open ocean. So we have our scale down here, and this is that epicenter that again is not the real one. We're going to use our compass to measure out 600 kilometers, and then we're going to draw a circle around the epicenter, and we're going to label it 1 hour. So 1 hour after the earthquake, the wave that was generated, the crest of it, is now at this distance because it's traveling at 600 kilometers an hour, and this is 600 kilometers, so that's where it was after an hour. If it's traveling at 600 kilometers an hour, how long has it gone after 2 hours? Well, 600 plus 600, so that's 1200. So for the next one, you're going to measure 1200 kilometers and again draw a circle and label this one 2 hours. So this is where the tsunami crest wave would be after 2 hours, etc. You're going to do this for 3 and 4 hours as well. So this should give you an idea of what it's going to look like with the wave traveling outward in all directions. But one more time, this is not the real epicenter location. I'm just using it as an example. Finally, we are up to part 4. And here we're actually looking at the speed of the P waves. This shouldn't really say tsunami waves. I'm just realizing this should say the speed of the P waves. What you're asked to do is to list the stations here in order from closest to farthest, in order of increasing distance. So whichever of the 6 you've determined is the closest to the epicenter, I want you to put that station here. And then the next closest, and then the farthest station should be down here. So you want to make sure you put them in this order, because when you calculate this last column, you're going to see a pattern. And if you don't have these in the right order, you're not going to see the pattern. I'm going to do the one from China just as an example. I'm not saying that this is the closest station, but we already have data for it. So the first thing you're going to do is put its epicenter distance. Now, how do we know that? Well, we calculated that way back when at the beginning, when we had the P and S arrival time, the time difference, and we used the travel curve to figure out the distance. So you're going to put that there. Then it's asking for the P wave travel time. And that one we determined in this video, where we looked at how long it took for the P wave to arrive at that station. And so this one is pointing to KMBO, but look at the one above at ICLSA. It took 5 minutes and 40 seconds for it to reach the station. So that's where we got that number. So these numbers in these 2 columns are things you've already calculated in general. You haven't calculated these for part 2, so you're going to have to look at the time travel curve and figure those out. Now you'll notice it says that it wants the time in seconds. This is minutes and seconds. So we just simply have to take 5 minutes and 40 seconds and turn it into all seconds. So the 5 minutes times 60 seconds in a minute is 300 seconds, and then we add the 40 to it. So we get a total of 340 seconds. So that's what we're going to put in here. Finally, the last column wants to know the speed in kilometers per second. So we take the kilometers and we divide it by the seconds. So 3,000 divided by 340 is 8.8 kilometers per second. And again, if you do this with these stations from closest to farthest from the epicenter, you're going to see a pattern. And that's what this last question asks you about. How can you explain the pattern that you're going to see in the numbers and how they change in this last column? Okay, finally, the last page. Yay! So these are just some concluding questions. You are going to need to look on the internet for the answers. It has some questions about the number of casualties that this particular event caused. And I will tell you, and I don't think I mentioned this earlier, that the total number of casualties here is going to be about 250,000. This was one of the most deadly disasters in recent times, and it was mostly because of the tsunami. So take a look at each of these questions. They're related to the lab that you did and these locations. And then there's another question down here looking at map 2 and the tsunami circles you drew. So that's the lab. I know that this was a lot of information, 3 different videos, but I really wanted to make sure you understood each part. And come see me at office hours if you have any questions.